You know, when we think about what's inside our phones, our minds usually jump to the big stuff, right? The processor, the camera. But what about the real unsung heroes? The tiny, almost invisible parts that make everything actually work? Well, today, we're going to pull back the curtain on one of the most important ones you've probably never even heard of.
Seriously, think about it. You've got processors, sensors, memories, screens. I mean, it's a whole jumble of parts, often made by totally different companies, sometimes years apart. So how on earth do they all talk to each other without the whole thing just, falling apart?
Okay, the easiest way to picture this is to imagine your phone is a huge, bustling city, and every single component is a citizen living in that city. But here's the twist, and it's a big one. They all speak different languages. And we're not talking English or Spanish here. In the world of electronics, the language is voltage.
And yeah, you guessed it, having all these different languages, these different voltages, leads to a massive problem. We're talking about a total communication breakdown that could literally brick your device.
So this whole mess basically boils down to two nightmare scenarios. First up, you've got what we call the whisper. Picture this, a super modern, power-sipping CPU running at a really low 1.2 volts. It's trying to send a message to an older sensor that's kind of hard of hearing. It needs a louder 1.8 volt signal. And then you've got the total opposite problem, the shout. That's when the old, high-voltage sensor just screams its 1.8 volt signal back at that poor, sensitive, low-voltage CPU.
So, what's the damage? Well, in that first case, the whisper. The signal is so quiet that the sensor either completely ignores it or worse, just dismisses it as random noise. Poof! Communication is dead. But the second case, the shout, is way more dramatic. It's like plugging your toaster into a power line for a freight train. It completely overloads the delicate circuits, and zap! The CPU is fried. Game over.
Okay, so with all this whispering and shouting, how does this digital city not just collapse into absolute chaos? Well, it's all thanks to a tiny, brilliant little diplomat, a universal translator. This is the hero of our story.
Let me introduce you to the level shifter. You might also hear it called a level translator. Its job sounds simple, but trust me, it's absolutely critical. It translates between all these different voltage languages. It makes sure that whisper gets amplified so it can be heard, and it takes that loud shout and dials it way down to a polite, inside voice.
So how does this little magic box actually work? Well, the level shifter is clever. It has two power connections. Let's call them VCCA for the low voltage world and VCCB for the high voltage world. Think of these as its two translation dictionaries. So when a low voltage signal comes in, the shifter looks it up in dictionary A to figure out what it's saying. Then it just flips to dictionary B, finds the exact same meaning, and perfectly recreates the signal. We're talking identical shape, identical timing, but now at that new higher voltage. It's a perfect copy, just louder.
Okay, let's make this real. Look at this, we've got an input signal here, a tiny whisper, coming from some newfangled super efficient chip. It's clocking in at just 0.7 volts. I mean, on its own, that signal is basically invisible. Most other parts in the phone would just look right past it. And now, look what happens after it goes through our level shifter. Bam! That little 0.7 volt whisper is transformed into this beautiful, clean 3.3 volt signal. The message gets delivered perfectly. No mistakes, no damage, no misinterpretation. I mean, that is a perfect translation. But, it's not quite that simple. Just like with people, you can't just hire any random translator for a high-stakes job. You gotta pick the right specialist for the type of conversation that's about to happen.
And here's where things get a little tricky. Communication isn't always a one-way street, right? Sometimes the CPU is talking to the sensor, but then the sensor needs to talk right back, and fast. So, how does our little translator know who's supposed to be talking and who should be listening at any given moment?
Turns out there are two main ways to handle this. First, you've got the smart interpreter. This kind of level shifter is brilliant. It actually has automatic direction sensing. It can literally sense which side is trying to talk, and it just opens up the channel instantly. It's perfect for things like I2C, which is just a common way chips talk, where the conversation is a super fast back and forth. Then there's the other type, the traffic cop. This one isn't automatic. It needs an external go signal on what's called a direction pin to tell it which way to let the data flow. Yeah, it's a bit more work to manage, but it gives you absolute control. So you might be thinking, why on earth would I ever choose the manual traffic cop when the automatic one is so smart? Well, it comes down to one word: speed. A manual control shifter can handle insane data speeds. We're talking up to 380 megabits per second. The automatic one? It tops out way, way lower.
So when you're dealing with really high-speed stuff, like talking to memory chips, that manual control isn't just a nice-to-have. It's absolutely essential to stop the signals from crashing into each other.
And this really gets to the heart of two different design philosophies. The traffic cop shifters, the manual ones, they're like a specialist tool. They give you unbelievable performance, but yeah, you gotta know how to handle them. The smart interpreter types, the automatic ones, are more like bodyguards. They're designed to make everything easy and safe, packed with built-in protections that just make an engineer's life a whole lot easier, and the final product more reliable.
So when you put it all together, we come right back to where we started. This tiny little chip is a true unsung hero, quietly working in the background, making our entire digital world possible. And I'm not kidding when I say they are everywhere. They are absolutely critical inside Apple's M-series and A-series chips, bridging that voltage gap between the super-fast, low-voltage processor cores and, well, everything else. You'll find them in giant industrial robots, in the cell towers that connect your calls, even in the little point-of-sale system at your favorite coffee shop. They are literally the invisible glue holding modern technology together.
You know, at the end of the day, all the massive, headline-grabbing tech breakthroughs that we see all the time, they rely completely on these small, clever solutions working perfectly in the background. Without the humble little level shifter, that whole high-tech city inside your phone would just go silent.
And that leaves us with a pretty wild thought, doesn't it? Today's challenge is translating, say, 1.2 volts to 1.8 volts. But what about tomorrow? What kind of translator are we going to need to bridge the incredible gap between the lightning-fast signals in a silicon chip and the complex, messy biological signals inside our own brains? Now that is a translation challenge for a whole new generation of unsung heroes.